Hello, welcome. My name is Ken Zhang, Application Engineer of Axiomtek. The purpose of this video is to demonstrate some of the built-in features of Axiomtek Network Appliance product NA-560. NA-560 supports both Intel Sandy Bridge and Ivy Bridge Core I CPU, 8 gigs of memory, and up to 8 gigabit Ethernet ports. In this video, we're going to talk about NA-560's LAN bypass function and how to program and control its onboard LCM. NA-560 has two pairs of LAN bypass. They are located at NIC number 1, 2, 3, and 4. For the purpose of this demonstration, I have connected a Cat5 cable tester on NIC 1 and 2. As you can see, the LED on the cable tester are not lit, which means there is no traffic flows between NIC number 1 and 2. Currently, this NA-560 is running CentOS 5.6, and I'm using Secure Shell to log in remotely. Axiomtek provides all the necessary library and sample codes to users who decides to develop their own application for controlling the LAN bypass. These two pairs of LAN bypass are connected to your onboard CPLD. User can write to the corresponding CPLD register to enable and disable the LAN bypass. Let's look at sample script module test. Module test calls program IORW to perform reads and writes to the CPLD. The CPLD then controls the LAN bypass relay. To understand how module test controls LAN bypass, let's look at our sample code IORW.c. First, we define the CPLD port address. Second, we define control register's address. And third, we use our B functions to write appropriate value to the corresponding register in order to control the CPLD. In module test, there were 8 options for controlling the LAN bypass. Let's look at option number 2, force enable off segments. Now please note, the LED on the cable tester, currently they are not lit, which represents there's no traffic flowing from NIC 1 to NIC 2. Now we could enable the LAN bypass. As you can see, the LEDs on the cable tester are lit, which means NIC 1 and 2 are now connected. Now we can also disable the LAN bypass by using option number 3. Now you can see the LEDs on the cable tester are off. After we understand how IORW writes to CPLD registers, then let's look at how module test enables and disables LAN bypass. In this example, we can see we use IORW write to CPLD port, in this case 800, to register F3 with value 127. By doing so, all the LAN bypass will be enabled. Right here, we can see we use IORW write to CPLD port 800, register F3, but this time with value 191. To disable all the LAN bypass. The last register we will talk about is called the power off status register. What this register does is defines the LAN bypass status when the unit is power off. Let's look at the module test tool. With option 1, we show all the CPLD register value. Right here you can see bit 1 and bit 0 are both 1, meaning when the unit is power off, LAN bypass is enabled. So we can change that. Okay, we can change the value to 0. And then we look at the CPLD register again. So now, as you can see, bit 1 and bit 0 of the status of the power off status register is set to 0, meaning when the unit is power off, LAN bypass is disabled. This concludes the demonstration of Axiomtek's NA-560 LAN bypass functions. Please visit us at www.axiomtek.com for support and product related info. Thank you.